everyone and welcome back to Study Room. Before starting the lecture, I would like to say, don't let the numbers bother you because mathematics is all about playing with numbers. So in today's lecture, we'll be discussing a new chapter of mathematics, that is factorization. Now, you'll be telling what is factorization and what will we learn from this chapter. So basically, factorization will deal with the algebraic expressions that you have already studied in your previous chapter. Now, after you are done learning the basic concepts of factorization, you will be able to solve the numerical problems of other chapters with much more ease. That means your time will get saved a lot after you learn the concepts of factorization. So, are you interested in learning a new chapter and thereby saving your time? Yes, I hope so. So let's get started. First things first, just recall the chapter of natural numbers that we have learned. In natural number, we know that any natural number can be represented as a product of its prime factors. For example, if we have a natural number 30, 30 can be written as 2 multiplied with 3 multiplied with 5. So, 30 has been represented as the product of its prime factors because 2, 3 and 5, each of them are prime numbers. So, 30 is represented as a product of its prime factors and thus this is known as the prime factor form. So, this was the case in terms of natural numbers. Now, what about when we talk of algebraic expressions? In case of algebraic expression, an algebraic expression can be written as the product of its factors as well. But in here, we use the word irreducible in place of prime. Like in case of natural numbers, a natural number can be represented as a product of its prime factors. In algebraic expression, an algebraic expression can be represented as a product of its irreducible factors, not prime factors. So what do you mean by irreducible factor? Let us first take an example of an algebraic expression that is 5xy. Now, I can write 5xy as the product of 5 multiplied with x multiplied with y. So, this 5x and y cannot be further reduced. 5x and y, each of them cannot be further reduced and hence they are known as irreducible. So, we have represented this algebraic expression as a product of its irreducible factors. So, this is what happens in case of algebraic expression. Now, let us take another algebraic expression that is 3x multiplied with x plus 2. Now, over here, this can be represented as 3 multiplied with x multiplied with x plus 2. So, we can say that this 3x and x plus 2 are the irreducible factors of this given algebraic expression. So, this algebraic expression has been represented as a product of its irreducible factors. Now, let's come to the main topic, that is factorization of algebraic expression. So, what do we mean by factorization of algebraic expression? Quite simple. We have been given an algebraic expression and we have represented it in the form of the product of its irreducible factors. Then, that is what factorization means. That means representing an algebraic expression in the form of product of its irreducible factors. The second important thing is that the factors in which you are representing can be a number, it can be any algebraic variable, or it can also be an algebraic expression. Let me explain this with the help of an example. For example, if I have an algebraic expression given to me as 2x multiplied with y plus 2. So this is an algebraic expression and I will be writing it in the product of its factors, that is irreducible factors. So it can be written as 2 multiplied with x multiplied with y plus 2. So over here, 2 is a factor, x is another factor and y plus 2 is another factor. 2 is a number. So I told these factors may be a number. X is a variable. Factors can be an algebraic variable. And y plus 2 is an algebraic expression. So it is an algebraic expression. So factors can be either a number, an algebraic variable or algebraic expressions. So over here we can say that this given algebraic expression is in the factorized form, or we can say that it is in the factor form because it is represented as a product of its irreducible factors. Each of the factors that has been given over here is irreducible. It cannot be further reduced. So it is already in the factor form. Again, we have 5x square y. So over here, 5 is multiplied with x, multiplied with x, multiplied with y. So we can see that this is an irreducible form. So again, this 5x square y is in the factor form. Similarly, the other examples like 3xy and then 5y plus 1 multiplied with x plus 2 is also in the factor form, because over here also we have 5 multiplied with another factor, that is y plus 1 multiplied with another factor, that is x plus 2. Now I told that the factor should be a number, algebraic variable or algebraic expression. Here 5 is a number, y plus 1 is an algebraic expression and x plus 2 is an algebraic expression. So all these given examples are already in the factor form, or we can say that it has been factorized. Now I'll be teaching you the first method, that is the method of common factor. We have been given an algebraic expression. We have to factorize it by using the method of common factor. Now the question given to us is 2x plus 4. This is an algebraic expression. Now, this 2x can be written as a product of its factors, that means 2 multiplied with x plus. The second term of the algebraic expression is 4. Now, 4 can be written as 2 multiplied with 2. I think this is an irreducible form, 2 multiplied by 2, because it cannot be further reduced. Over here, now what we have to observe is, from these two terms, we have 2 multiplied with x as the first term and 2 multiplied with 2 as the second term. From these two terms, we have to observe a common factor. Just like the name suggests, common factor method. So we have to select a common factor. So is there anything common? Yes, there is. We have 2 in the first term and 2 in the second term. So we can say that 2 is the common factor of both the terms of the given algebraic expression. So we will take 2 outside and then we will take a bracket. Now in order to complete the first term, we have 2 multiplied with x. We have taken 2 outside common, so we are left with x. So we will have 2x. Because when this bracket opens, these two numbers gets multiplied with each other, so we have 2x. Now in order to make the second term, we have already taken 2 outside as a common factor. So we are left with another 2. That means we have to write plus 2. Now just multiply both of them. 2 multiplied with 2 gives plus 4. We are having the second term as plus 4. So this is our final answer. That means 2 multiplied with x plus 2 is the answer, or we can say the factorized form of the given algebraic expression using the common factor method. What we did, we just broke it into common factors, or we can see that irreducible factors, and then we took out the common thing outside and gave bracket and the remaining factors inside the bracket. Thus, the final answer obtained is the factorized form of the given algebraic expression. Now, if you have a doubt that is my answer correct or not, how can you check it? Just go the reverse process. That means you have this 2 which is multiplied with this entire x plus 2. Open the bracket and check. If I open the bracket, let's say I have 2x plus 2 as my answer and I'll try solving it. I'll multiply 2 with x, which gives me 2x. This is multiplication of a monomial with a binomial. I've taught you earlier in the previous chapters. Again, we have 2 multiplied with the second term, that is 2, which gives me 2 multiplied with 2. I'll be left with 2x plus 4. Isn't this the question that was given to me? Yes, it is. So my answer is correct. So this is the way in which you can check that whether the factorization you have done is correct or not. Just go back, go the reverse process, you'll get the question. Let's try solving another problem with the same method, that is method of common factor. The question given to us over here is an algebraic expression, that is 5xy and 10x. That means we have 2 terms. Now, let us write it as a product of its irreducible factors. So 5xy can be written as 5 multiplied with x multiplied with y. And then the next term is plus 10x. So this can be written as plus. Now 10 can be broken as 2 multiplied with 5 multiplied with, now we have x. So this x can be written as x. So 10x has been reduced to a form of 2 multiplied with 5 multiplied with x. Now What we have to do? We have to observe the common factors in both the terms. So we find that we have 5 in the first term and we have 5 in the second term as well. Now, we have x in the first term and x in the second term as well. Now talking about y, it is there in the first term but not in the second term. So it is not a common factor. 2 is there in the second term but not in the first term. So it is also not a common factor. So the common factor of both the term is this. That means 5 multiplied with x. That gives us 5x. So we will be taking this common factor from both the terms outside and we will give a bracket. Now in order to make the first term, we have taken 5x outside. We need a y to be multiplied with 5x. So I'll be writing y. Now in order to make the second term, we have taken 5x already outside. In order to make plus 2 multiplied with 5 multiplied with x, we have to multiply this 5x that we have taken outside with 2. Because 2 is the only term that is left. 5x has been taken outside. So I'll be writing plus 2. So this is our answer of the given algebraic expression in the factorized form, or we call it as the factor form. And we have solved it using the method of common factor. Should we solve another problem? Yes, let's do it. So the other problem that we have is 12a square b plus 15ab square. Now, talk about the first term, that is 12a square b. This can be written as 12 can be broken and written as 3 multiplied with 2 multiplied with 2. I have broken 12 as a product of its prime factors. 3 multiplied with 2 is 6, 6 multiplied with 2 is 12. Now a square can be broken and written down as a multiplied with a. And this b can be written as multiplied with b. Talking about the second term, we have 15. 15 can be written as a product of its prime factors, that is 3 multiplied with 5 gives us 15. And then we have ab square, that means multiplied with a multiplied with b square can be written as b multiplied with b. I am reducing it in a smaller form so that you will be able to understand it better. Now, let us check the common factors. This is the next step. In order to check the common factor, first we have 3 in the first term. 3 in the second term as well. So 3 is a common factor. We can say that yes, 3 can be taken outside. It is a common factor. Talking about 2 and 2, no. 2 and 2, we don't have 2 in the second term. So it won't be a common factor. Next up, we have a. Yes, we have another a in the second term as well. So we'll take a outside again because we have to take out the common factors outside the bracket thing. Next up, we have b. Yes, we have a b over here as well. So b will also be taken out as a common factor. Now what we have to do is, we have to write the leftover thing within the bracket. So in the first term, we have taken 3 outside, 1a outside and 1b outside. That is 3ab outside the bracket. What we are left with? We are left with this 2 multiplied with 2 which gives us 4 and this capital A. So we have 4 times A. Now we'll give a plus sign because we have a plus sign over here. Now from the second term, we have taken 3, capital A and B outside. So we are left with this 5 and small b. That is 5b. So this will be our answer of the algebraic expression in the factorized form. That is 3ab multiplied with 4a plus 5b. The next question that we have with us is an algebraic expression, but here the difference is we have 3 terms. That means it is a trinomial. So let's try solving it. It's just the same. The process is just the same like in binomial. So let's follow it. First, 10x square can be broken and written down as a product of its irreducible factors. 10 can be written as 2 multiplied with 5. X square can be written as x multiplied with x. Now we have minus 18x cubed. So it can be written as minus. Now 18 can be broken down and written as 2 multiplied with 3 multiplied with 3. Because 2 3 times gives us 6. 6 3 times gives us 18. X cube. X cube can be written as x multiplied with x multiplied with x. I taught you this in the chapter exponents. Okay. Next up we have the third term as 14x to the power 4. This 14x to the power 4 can be written as 7 multiplied with 2 multiplied with x multiplied with x multiplied with x and then another x. Why? Because x will be multiplied with itself 4 times because the power over here is 4. Now, what are the common factors that we can take out? Let's see. We have 2 in the first term, 2 in the second term and 2 in the third term as well. So we'll be taking out 2 outside, and then we have x in the first term, x in the second term, x in the third term. So we'll be taking x outside as well. Now we have x in the first term, x in the second term, and x in the third term as well. So we'll be taking another x outside. Now we don't have any other common factors left. So what we'll do, we'll make a bracket and then write all the leftover factors. So in the first term we have taken 2x and x outside the bracket. We are left with only 5. So we'll be writing 5 over here. Now in the second term we have taken 2, this x common outside. So we are left with 3 multiplied with 3, that is 9, multiplied with this x. That is 9 multiplied with x gives us 9x. But here we have a minus sign. So I'll be giving a minus sign and then 9x. Over here we have 2 multiplied with x and x. We have taken this outside. So we are left with 7 multiplied with x multiplied with x. This gives us plus of 7 times x squared. So our final answer will be 2x squared. Within brackets we have 5 minus of 9x plus of 7 times of x squared. So this is the factorized form of the given algebraic expression. Now we'll be learning a new method of factorization, that is factorization by regrouping the terms. Now you'll ask me that, ma'am, you already taught us factorization by the common factor method. So what is the need of learning this regrouping method? So the answer to this question is, many a times we get algebraic expressions in which we cannot find any common factor from all the terms. For example, the algebraic expression given to us over here, that is 2xy plus 2y plus 3x plus 3. Is there any common term from all the terms? No, we do not have any common factor which is common to each of the given terms. So, in such a case where an algebraic expression doesn't have common factors to each of the terms, there we use the regrouping method. Now, what we do over here is, we have to regroup the terms. That is, here in total we have 4 terms. We will be grouping 2 terms at a time. So, we will group this first 2 terms. That means 2xy plus 2y. And then, the third and the fourth term will be grouped together. Now, you'll ask me that how to group the terms. We have to group the terms by trial and error method. We have to group the terms in such a way that from the 2 terms that we are grouping together has a common factor. For example, over here I told that I'll be grouping 2xy with 2y. So over here I can see that in these 2 terms we have 2 and y as a common term. Again, I grouped 3x with 3. In both the terms we have 3 as a common number. So regrouping the term has to be done with a trial and error method. You have to try regrouping the terms and then the regrouping that suits the best. That means the regrouping in which you get a common factor will have to be preferred. So over here I regrouped the first and the second term and the third and the fourth term together. Now what you have to do is forget this part. Forget the third and the fourth term. Focus on the first and the second term. Do we have any common factor in the first and the second term? Yes, we have. We have 2 and y as the common factor of the first and the second term. Why? Because 2 is there in the first term and it is there in the second term as well. Similarly, y is present both in the first and the second term. But talking about x, no. X is there in the first term but not in the second term. So it will not be taken outside as a common factor. So we took 2y outside as a common factor. Now, in order to make the first term, we have taken 2y common. What is left? We are left with x. So the factor that has been left with us will be taken within the bracket. So that when we multiply 2y with x, it gives us the first term, that is 2xy. Next up, from the second term, we have taken 2y common outside. So what is left with us? Wait, I'll show you. This 2y can be written as 2y multiplied with 1. Now when we have taken 2y outside common, from this term, we are left with 1. And here we have a plus sign, so we'll be writing plus 1. So when I take 2y common outside, that means we are left with 1. 2y multiplied with 1 gives us 2y. Now forget this first and second term and focus on the third and the fourth term. From here, what we have to do is, here we had a positive sign, so I wrote a positive sign. What we have to do is, from both these third and fourth terms, we have to take a common term outside. Now from 3x and 3, what is the common term? 3 is the common term from the third and the fourth terms. It is a common factor. Now when we have taken 3 outside as a common factor, in order to make this term, we have to multiply x, because 3 multiplied with x gives us 3x. Now we have taken 3 outside from this fourth term. So what we are left with? We'll be left with 1, because this 3 can be written as 3 multiplied with 1. Now when I've taken 3 as a common factor outside, I'm left with 1. And we have a plus sign in between. So I'll write added with 1. Now this is the expression that we get after first regrouping the terms. Now we have not done any sort of factorization. We have just regrouped the terms, in the first step. And then what we did, we took the common factors outside. Now what we have to do is we have to focus on this term and this term. Now again we have this as one term and this is the other term. In both the terms, we have to take out the common factor outside. So this 2y multiplied with x plus 1 can be written as 2 multiplied with y multiplied with x plus 1. And this 3 multiplied with x plus 1 can be written as 3 multiplied with x plus 1. So from over here, I can see that this x plus 1 is a common factor in both the terms. So I'll be taking x plus 1 outside as a common factor from both the terms. And then we'll have to write a bracket. Now within the bracket, we have to write the leftover terms. So from the first term, when we have taken x plus 1 common outside, we are left with 2 times of y. So we'll write 2 times of y. And from the second term, when we have taken x plus 1 common outside, we are left with 3. So plus 3. So this will be our final answer when we get this algebraic expression and we have to factorize it. So over here we use the regrouping method, and this method is used when we do not have a common factor from all the terms. Then we have to regroup the terms, and from the regrouped terms we have to take out common factor, and in that way proceed our problem. Next up we have another problem to solve, and over here let's see what is the method that we'll be using. So the question given to us is an algebraic expression which reads 6xy minus 4y plus 6 minus 9x. Now just observe, is there any common factor from all the terms? No, there is not a single number which can be taken outside as a common factor from all the terms. So what is the method we'll be using? We cannot use common factor method. Which method we'll be using? We will be using the method of regrouping the terms. So let's use it. Now, which terms to regroup? Over here, we can focus that if we regroup the first and the second term, and then the third and the fourth term together, then I think the problem will get easier. Let's check, and if not, we'll move on to the next trial. Let's check grouping the first and the second term, and then third and the fourth term together. So in this case, what we get is, we'll group the first term and the second term, that is 6xy minus of 4 times of y. And we'll be grouping the third and the fourth term together. But now I'll give a plus sign before, and I'll be writing this fourth term before and third term later. I'll explain you why I'm doing so. So this is 9 times of x, this is the fourth term, and I'll regroup it with plus of 6. Now, just forget this part and focus on the first part. Now from the first part, what can be taken out as common? First of all, let me write it in a much more simpler way. So 3xy can be written as 2 multiplied with 3 multiplied with x multiplied with y. And minus of 4y can be written as minus of 2 multiplied with 2 multiplied with y. This is the way in which we can write this. Now let's try taking out the common factors. So in the first term we have 2 in the second term as well. In the first term we have 3, but we do not have 3 in the second term, so it is not a common factor. Again we have x in the first term, but x is not there in the second term, so again it is not a common factor. Talking about y, yes, we have y in the second term as well. So 2 and y are the common terms from these two terms. So we will be taking out 2 and y. So what we are doing is, after regrouping, we are again using the same common factor method. What we are doing is using the same common factor method. So 2y has been taken outside. To make the first term, we are left with 3 and x. So 3x will be multiplied in order to make the first term. Now from the second term, we have taken 2 times y outside. We are left with minus of 2 inside. So we'll be writing minus of 2. Now this part is done. This was all what we have done from the first part. We are left with this part, that is plus of within bracket minus 9x plus 6. Now what to do? We'll write it in a simpler form at first. So we have minus 9x. This can be written as minus of 3 multiplied with 3 multiplied with x. Because if we have minus 9, it can be written as minus 3 multiplied with 3 and then multiplied with x gives us minus 9x. Now we have plus 6. So 6 can be written as 2 multiplied with 3, the product of its prime factors. Now what we'll do is we will take common factors outside. Now focus on the common factor. Is there any common factor? Yes, we have 3 in both the cases. 3 in both the cases. Now what I'll do is I'll take minus 3 outside as common. I'll explain it to you why I've taken minus 3 outside. When I took minus 3 outside, the first term that I am left with is 3 times of x, because minus 3 has been taken from this term. So we are left with 3 times of x. So this gives us 3x. Now, just because I took minus of 3 common outside, so here I am left with 2. But I have taken a minus sign outside, but this term is actually positive. So in order to make this term positive, I'll be writing minus of 2 is left inside, because when I multiply minus 3 with minus 2, it gives me plus of 6, which is this term. I have to match that this term which I'm writing minus 3 and minus 2 should match with this term. Now the reason why I took minus 3 outside, because when I took minus 3 outside, I got within the bracket 3x minus 2, which is equal to the term that we got within the bracket from the first term, that is 3x minus 2. So this is the reason why I took minus 3 outside. So we were left with 3x from the first term, and when minus 3 is taken outside from the second term, we are left with minus 2, because minus 3 multiplied with minus 2 gives us plus 6. Now, what to do? Again, we are left with two terms. One is 2y multiplied with 3x minus 2. Other is minus of 3, 3x minus 2. Now, the common terms from these two needs to be taken outside. So, the common term is 3x minus of 2. This is the need why we have taken minus 3 outside in order to make these two terms common. So, 3x minus 2 has been taken outside. So, what we are left with is 2y from the first term, because 2y is multiplied to 3x minus 2. And when from the second term we have taken 3x minus 2 common outside, we are left with minus of 3. So minus of 3 will be in the second term. Now this 3x minus 2 whole multiplied with 2y minus 3 is our final answer. And we can say that it is the factor form or the factorized form of the given algebraic expression. And the method that we used is the method of regrouping the terms.